Chapter 1.2, exercises 1 through 10, page 102. This has to do with domain and range, attributes of the function, and we're going to go through exercise 1 through 4. Determine whether the formula determines y is a function of x. If not, explain why not. So we're going to be giving these functions, these equations, and here we have number 1, y equals the square root of quantity x minus 4. And to do this, we could use a graphing calculator. I'm going to go ahead and just make a quick little table. We're going to have an x, y. And if we start out with 0, if we plug in 0, we get 0 minus 4. Well, the square root of negative 4 does not exist as a real number, so it just does not exist. And we go on 1, same thing. 1 does not exist, 2 does not exist, 3 does not exist. But if we get to 4, if we input 4, we get square root quantity 4 minus 4 is going to be square root of 0, which is 0. So that's where the function starts to exist at x equals 4. And if we plug in 5, we have 5 minus 4, which is square root of 1, which is 1. If we plug in 6, we get square root of 26 minus 4, which is square root of 2, which is about 1.41. And then if we plug in 7, we get 7 minus 4 is square root of 3. And if we plug in 8, we get square root of quantity 8 minus 4, which is square root of 4, which is 2. And so if we plug in, let's see, 1, 2, 3, 4, 5, 6, 7, 8 along the x-axis, and 1, 2 along the y-axis, all we're going to need here. And functions do not exist until x equals 4. So there we have it, x equals 4, and we have 5, comma 1, and we have 8, comma 2. So the function is going to look like this. And y is a function of x. So we say yes, a function. Okay, that is a function. That is our correct answer. Go on to our next odd number problem, which is 3. We have, in this case, instead of y equals, we have x equals. What we're going to do is solve for y, and to do that I'm going to use the symmetric property of equality and just switch these elements around this equal sign, and we're going to go about solving for y. Divide both sides by 2. We have y squared equals x over 2. If we take the square root of both sides of this equation, we get the square root of y squared, which is y, equals plus or minus square root of x over 2. And we have plus or minus. That's going to really change things for us. We have a coordinate plane here, and it's going to be kind of like problem 1. So I'm just going to make a quick sketch here. If we have square root of x over 2, it's going to look like this. And this other function is going to be negative square root of x over 2. So given the sketch of these two functions, you solve for y, you get two functions essentially. And I made this vertical line here. You see that at the origin, vertical line touches once, but once we get to the right of origin, we touch twice. So we say this is not a function, and it says if not, give reason why not. Well, we've tested, we can say there are two different outputs for one input, but we can just summarize that as fails the vertical line test, which I abbreviate here as VLT. Okay, next we go on to problem number 5, and that's just we have 5 through 8 use the vertical line test to determine whether a curve is a graphically function. So we get, here we have this curve, which is right here in blue, and I made this vertical line, and this black vertical line. We see that no matter where we go with this black vertical line, only touches once. So we say, yes, function, okay, passes vertical line test. Okay, and then we go on to our next auto problem, which is 7. And here I made a vertical line, this black one here, touches once, but once we go to the right of this point here, it touches twice. Touches twice. We can just say touches more than once. Not a function. Fails vertical line test. So there we go. And problem 9. In exercise 9 through 16, find the domain of the function algebraically and support your answer graphically. On problem 9, we have f of x equals x squared plus 4, and this is what we would call a polynomial function. And you may have learned, I hope you learned in Algebra 2, that all polynomial functions have a domain, which I will put D colon. Our domain is going to be all real numbers, which we write in interval notation as greater than negative infinity, less than infinity. And then it says that's determined algebraically. That's not even, I didn't even really use algebra other than understanding of what a, just kind of the rule of all polynomial functions have all real numbers as their domain. As far as support graphically, we can just graph this function quite easily. We have, let's see, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3 to the left, x, y, and we'll just say our y-intercept is at x equals 0 is 4, and then the function looks like this. It's just a standard quadratic current function shifted 4 units up. That's all it is. And if we ran on this a vertical line test, we would see that this is a polynomial function, and this function continues all the way from greater than negative infinity to less than infinity. So anyway, that's it. So hope it's been helpful to you. I thank you for viewing.